And these are all herbal-based preparations. And so this is the first one that he talks about is yarrow. And it's interesting the way that he talks about these things. And the thing about these preparations is he talks about them in an interesting order, because he starts with yarrow, and I never thought there was much of an order to it until the other day when I read it, and I sort of got it why he was talking about it. And so he starts off with this Venus, the 502, the yarrow preparation, which is this one here. And he starts talking about potassium, and he starts by talking about transmutation of elements quite quickly in the piece, and he starts saying that the idea of transmutation of elements is that various elements under certain conditions can be transformed into other elements. And I was thinking about this, and he says that the potassium can be turned into something like nitrogen. And I was talking to a soil science doctor one time, and one of the things about these, you know, a gas spectrometer or whatever they're using to determine what elements there are in any given situation, is that they're reading atomic weight. Okay? So they're sort of going, oh, we've got something of an atomic weight of 20. That's it. So, oh, okay, so we call that magnesium. That's probably not magnesium's number, but so we say, okay, that's magnesium. And now, a good example of this, one of the things that you'll notice that when you do soil tests during the winter time, you'll quite often find that you'll get quite high readings of magnesium and sodium. And then when you come along in the summertime and do a soil test, you'll find that your levels of those two will drop, and you'll get higher levels of calcium and potassium. And so what is happening there is that in the periodic table, you've got sodium and potassium are sort of brothers, and magnesium and calcium are brothers. And so if we look at the atomic weight of these things, we can see that potassium is 39 and sodium is 22. So there's, what's that, 17. And when we come to oxygen is 16, 15.9999. And so what transmutation of elements says is that reading for potassium that we get in the summertime when the soil is aerated is actually the sodium plus oxygen. Okay? And the reason that we get this higher sodium reading in the winter is because the soil is more waterlogged, and so less oxygen, and so it reads as sodium. But in the summer, when we take the soil test with more air in the soil, we've got more oxygen. Sodium plus oxygen equals potassium. You see what I'm saying?
So you're saying it's mistaken identity.
Yeah.
So it's NaO instead of Mg.
Yeah, that's right. So when we're reading calcium in the soil, it's actually magnesium oxide. Yeah, that's right. Magnesium oxide has the same atomic weight as calcium does. That's the point.
I see what you're saying. Yep.
And that this is the basis of transmutation of elements. Magnesium is 24. So you could say magnesium plus nitrogen equals potassium.
But because you have those two in the soil doesn't mean you're going to get the same response as you would for potassium.
But why not? It's the same atomic weight. The plant's going to read it the same. Like hydrogen is 1, so to make up that extra 1, magnesium plus hydrogen, where are we going? Magnesium plus nitrogen plus hydrogen equals potassium. So under certain conditions, we'll break down the potassium back into magnesium, nitrogen and hydrogen. That's basically what he's saying.
And that sort of
would the
indicates that,
identical atomical weight also equate to the identical molecular structure with regard to the protons, neutrons and electrons?
Yep.
Or are they just, are the two?
Well, as a molecule, you know, like we're saying the potassium is actually just one element,
Yeah.
and we're saying over here we've got a molecule of exactly the same atomic weight. And what Kavan is saying is that they're going to act in exactly the same way. And so we're reading that molecule as that element.
Is the plant doing the same thing?
Well, that's what they're saying, yeah. That's what
In
Kavan...
pine trees, you see that very much on mafic soils. The potassium overrides the magnesium. Pine trees go yellow. And we noticed very much in the
That's
first
the binding
trees.
of the element to the soil.
Sorry.
That's the binding of the element to the soil. How much do you...
Well, you don't see the magnesium as your green, but the potassium overtakes the magnesium sites. The trees just turn yellow.
Yeah, I get it.
How does that happen? There's just more potassium.
Right, it's the availability, because they're very similar.
Right.
The plant must be able to...
Oh, I see what you're saying, because they're sitting next to each other, aren't they?
Yeah.
Yeah.
That's
Oh, well, they're friends
Yeah,
anyway.
Does that happen at certain times of year or all the time?
Spring.
Spring, so it's lack of oxygen in the soil because of water
No, it wouldn't be.
and temperature.
Temperature.
It would be
Affects the
temperature,
metabolic
of it,
process.
yeah, just as it starts to come away.
That'd be interesting. How much is your nitrogen getting bound up with the magnesium?
If that's the case, then if we add other elements, we manipulate them, we don't need nitrogen, we don't need to add specific.
Well, that's
That's what you're saying.
well, yeah, that's what it's saying.
So our phosphate problem can be solved if we can manipulate other elements which can react like phosphate.
Yeah. So if you've got a high magnesium soil, let's say we're in Australia and we've got a really high magnesium soil, 48% magnesium. How can we use the magnesium as the base substance by which we make other elements? Is what you're saying.
Yes, well, the plant absorbs it as sees as our element, yeah.
So, you know, we could turn magnesium into calcium maybe, and magnesium into potassium. Okay, so that's this image of transmutation here.
okay, well, so I'm maybe going ahead too quickly, but so we're basically saying then that the preparations give us the ability to manipulate that supposed transmutation of elements.
That's what he's essentially saying. That in, you know, putting it in that context,